So yes, my name's Rhys. I work at the Financial Times. And it's happening again, the fonts are missing. Can someone at the back maybe look at that? It's going to be interesting because it's about kind of managing failure and my slides aren't working, which I think is quite thematic. So anyway, the title of the talk is A Field Guide to the Financial Times. So a little bit more about me. I've worked in tech for about 10 years, but for most of that as a front-end developer. But gradually moved more into tooling for the front-end team I was working on. That gradually evolved into becoming the co-lead of the Financial Times reliability engineering team when that was set up. And I'm also a bird watcher, which kind of gave me the idea for the structure of this talk. It's about providing a field guide for all the tech at the Financial Times. So a field guide is a book that helps you identify objects of natural occurrence. So we're going to look at the tech at FT as kind of a natural ecosystem that we're trying to provide a guide to. So I will cover why the FT needs a field guide, how we've used a Neo4j graph database and GraphQL to organize it, and some approaches we've taken to filling in the details. I'm really looking forward to finding out which other bits of my slides are missing. So this, I think that says, what does that say? Why the FT needs a field guide. Okay, so this is ft.com. This is our flagship product. Somewhat unfashionably, it makes a profit and reports news based on the facts. So that's our main website. We also have lots of other online properties, loads and loads of business and news websites. That's FT China, telling it like it is. And we have lots and lots of internal things. So from left to right, we've got Fast Charts, which is our chart building tool that the editorial teams use. We use lots of off-the-shelf products, such as Salesforce, for doing lots of internal tasks. And we have lots of other little tools that we use internally. So there's our change request API Swagger thing. As well as all this digital stuff, we're also a physical company. 6 days a week, we print the newspaper and distribute it all over the world. And to complicate matters further, we're always at the mercy of the news cycle. So we get a lot of Brexit news at the moment, and we get emails like this coming around saying, be careful with your tech at the moment. And last week was interesting because we had a production incident which we had to delay fixing properly because we didn't want to risk being able to publish news on probably the biggest news story in the UK for several years. So our operations team, they keep an eye on all this. As you can see from those screens there, there's a lot of individual services to keep an eye on. And in amongst that is loads of really old, legacy, horrible systems. I asked around for some stories about dealing with this, and I got this from one of our tech directors. That's something that made us quite a lot of money. No one really knew anything about it anymore. I think the key fact here is that it was unowned and unknown. So that's where we were, and then about 5 years ago, that situation mushroomed. That wasn't by accident. So previously, we had kind of quite a traditional tech company. A lot of decision-making architecturally-wise was centralized. We had loads of monoliths. We had a data center, and we released code really, really slowly. And what this kind of meant was we weren't really able to respond to opportunities in the market. We'd see competitors such as The Guardian and Washington Post releasing really interesting news-telling features, and we were just moving too slowly to be able to take advantage of the market. So we adopted a few approaches to deal with this. So one of them, the FT, were early adopters of microservices. We talk quite a lot about them at conferences. And microservices mean instead of having one big service, you've got lots of small independent services which do small jobs themselves. And this allows you to be a lot more flexible with your tech choices. It allows you to release and try out ideas a lot quicker. And around the same time as well, we moved away from having centralized decisions. So this is a quote from one of our tech directors, that we moved towards following more of a free market structure for making tech decisions and trusting teams to make the right decisions. So some examples, things used to be hosted in a data center, now we use the cloud, mainly AWS. We used to have a standard platform for deploying, and now we encourage teams to just pick the SaaS service they particularly want to use. We used to mainly write in Java, now it's a mix of different languages. And we used to put a lot of kind of ivory tower architectural thinking into things, no matter how big the project. Now we just tend to try stuff out and see what works and iterate on it quickly. So another quote from Matt, that the upside of this is teams left to their own devices, choose what's best for themselves and the business in the long term. Now, I basically agree with that statement as part of the teams that embrace this process. But now, 5 years on, the word long-term jumps out at me as being quite optimistic, because what happens is this. You have engineering teams and engineers. They build lots of new cool stuff, and then they tend to move on. So here's some examples of that happening at the FT. Our image service serving all our images on all our, sorry. Yeah, so that was run by one person and they left. We have, sorry, losing my voice. So yeah, a number of examples of where people who built things have moved on. And even if you don't embrace this liberalized tech decision-making, 5 years is quite a long time in any tech company. People leave, business priorities move on, and stuff which used to be the thing that everyone wanted to work on and was well maintained, that's no longer the case. So the reason we need a field guide is to help us navigate all this legacy tech. And what we're trying to go away from is things being unowned and unknown to being owned and known. Okay, so this is supposed to say using Neo4j and GraphQL to model this. So we have 3 priorities to improve the reliability when the new team was set up. We need to reaffirm who owned which bits of tech, improve the information we had about those bits of tech, and determine the health of that tech at any given time. So I'll mainly talk about the first 2 today. So a reminder of the main audience for this in the first instance is our operations team. We do embrace DevOps at the FT. All our development teams, they operate the services in production, but we do have a centralized operations team who deal with incident management. Their first line support as well, and they have a broad knowledge of all our tech, but they need to know which troubleshooting approaches to apply to which systems, and if those don't work, who can they contact to escalate. So we've tried to get this information together. In the past, we've got several past attempts at this, but they tended to fail because the information in them had a few problems. It was too inert, so people would enter it once, and it would get out of date, and no one would update it again. It was too brittle. Someone would have responsibility for it, and if they moved around in the company or left, then that would no longer have ownership. And it's too discrete, so particularly with the microservices architecture, things are very connected, and the data source documenting all this didn't really reflect those levels of connection. So a natural question our operations team will ask is, who can help me with a particular system? So it's very tempting on each system to put some names of people next to it. But this is an intuitive way to model it, but it's very brittle because people move on. And relational databases, if this is where you store your documentation, this kind of leads you down this route because it's actually, despite them being called relational databases, it's quite hard to model really complex relationships between things. So you might end up with a system owner property on a system, but actually in real life, that person is connected to the system because they are perhaps a tech lead of a team, but you can lose that detail because it's easier to model it as a direct property. So who here knows something about graph databases? With a show of hands? Okay, I'll give a very rough. So the idea behind graph databases is it's basically a NoSQL database, but they have some optimizations to make following relationships between things very, very performant. So they're designed to model complex relationships. So you don't need to simplify the details which are contained in those relationships. So previously, with a relational database, you might ask a question like, how can I assign the right person to this system? Whereas with a graph database, because it's got the power to follow relationships, you can just ask the question, how can I connect someone via some chain of relationships to this system? And then you're faced with the question, well, what do I connect my system to? Going through from the very stable long-term things, such as companies, through to employees, which change all the time. So my advice here is to model the stable stuff first. Even though the question everyone's asking is, who can help me with this? That's not going to help you if that person's left. So go for something a bit more stable. So for example, what we do is when a system is created, we give it a unique code, and we use that code to connect that to a team. So this is what that looks like in graph form. We have a system going to the team that delivers it. That may go through a few loops, going up through parent teams, and eventually that gets through to the tech director. So what we have there is a connection via some stable bits of the organization, such as teams, going to a person who's senior and is ultimately responsible for it. And that's quite easy to maintain. Then once we've got that, we can build up all the interesting stuff. So we can have relationships between people and systems, which is a knows about relationship. Or for instance, with GDPR, you want someone who's responsible for managing the data. So we have a GDPR data relationship. And interestingly, on the last, related to the last talk, we're now thinking of modeling postmortems in this as well. So you can have all these kind of like has follow-up action. And if any of those connections are lost, we still have that underlying connection to the tech director. So we have someone who's responsible that we can go to and ask to give us more information. So this system is called BizOps, and our idea is to kill all spreadsheets. So all this kind of information in most organizations, people will make a spreadsheet to collect this information. So we want to kind of phase that out of the organization and have BizOps as the place to store useful information about anything, and it's all connected. So in this database, we want it to be self-service. We don't want to put loads of data in and then make it difficult for that to come out. So some principles behind that is we want it to be self-service. No such thing as a power user. So essentially, everyone has full, rich access to the data. We want it to be easy to extend that in future without much development effort. And we want it to have a good API so that developers can build on top of it, but also not everyone interested in this information is going to be technical. So we want to provide good user interfaces as well. So looking at the APIs we could build, we considered REST, but that's really not very good for exploring connected data. I don't know if anyone's worked with REST APIs for this. You just end up writing loads of code to traverse relationships. So we considered doing canned queries, where we have an endpoint where you pass in some parameters that populates the query. but that's limited by our imagination, and we want people to be able to ask whichever questions they want of this data. So to the rescue, GraphQL, which is an API language designed for traversing graphs. It's purpose-built for this. And then, luckily, around the time we started this project, Neo4j, the database vendor, they released a library to provide a GraphQL API in front of the database. So this is how you interact with the data as this is part of the development workflow as a user interface for it. And you can see you write a query which explores some of the nested data, and the data that comes out basically resembles that. So it's quite intuitive, and under the hood it writes that very complex query for you, which I don't particularly want to spend all my time writing stuff like that. So it's quite a powerful tool. So using GraphQL, there's a few big wins. As I just showed, it's quite user-friendly. It's future-proof, so as we add more and more interesting things to the data model, the API just grows with that. We don't need to put any extra thought in. And because we're avoiding the users having to traverse and make lots of API calls, we have a single API call and a single database query, which is very efficient. There are some downsides. It is possible to write a very expensive query accidentally and knock out the database. That hasn't happened yet. Caching is a bit difficult with GraphQL. And as a write API, I'm not convinced it really works yet. But compared to the massive benefits of using it, those are quite small things. So as well as that, we've defined our custom YAML schema. I'm sure some people will hate that. So from that, we generate the GraphQL schema, and we provide some metadata, which then powers a suite of React components. And we have a UI which allows people to interact with any of the data. Again, we just add things to the YAML schema if we want to model new things, and the UI just emerges out of that naturally. So I don't know if anyone's seen The Social Network, but there's a scene in it where Mark Zuckerberg adds the relationship status. He basically goes home, types in relationship status, Boolean or something, hits return, and goes, it's done. And I remember watching that with my non-programmer friends at the time, and going, yeah, right, it's never that easy. But with this, it really is that easy. It's a great set of tools. So the cool kids, otherwise known as the Neo4j developer relations team, they're calling this GRANDstack. For modeling connected systems, I really recommend looking into it. So DevOps, our new way of modeling all our systems, because of the modeling choices we've made and the tech stack, we've got some confidence that it won't just end up being a graveyard of out-of-date documentation like our previous attempts. And we're giving unlimited access to the data of any person in the organization. Okay, so that's supposed to say filling in the details. That bird in the bottom is my spirit animal, by the way. So as I mentioned before, this isn't the first time we've tackled this problem. So the approaches I've just explained, they're tackling the problems of it being too brittle and too discrete. We've still this problem of inertness, that the data gets entered once and never updated. So how do we approach that? So firstly, there's no such thing as human error. People are fallible. That's not their fault. If people are not updating the data, then it's your systems and your processes for getting people to do that are at fault. So expect people to not be good, but build things into how people enter the data to improve that. So taking you through a few approaches. If some other system is a source of truth, for your information, for instance, we've got lists of GitHub repos, or we've got an API in the organization which lists all our staff. Use that as a source of truth and automate pushing it into your connected data store don't expect people to do that manually because it'll be less good than a machine doing it. So I don't know how familiar the phrase more carrot, less stick will be outside of the UK, but essentially means don't beat people into doing things, give them gifts for doing things. So we've just built a new monitoring system which uses the data from BizOps to organize it. So if you want the alerts from your new system to go to your team, then you need to connect them properly in the database. One thing we've just adopted recently is using gamification. So we have a scoring mechanism for the quality of documentation, and we've created some dashboards to help teams see how good their information is and to drive them to improve it. And so this was a screenshot taken the other day. We launched it probably about 2 weeks ago, and at the time, I think the top score was probably about 40%. Now we've got lots of teams competing to be up towards 80 and 90%. I think I know it's a success because teams are finding little bugs in our scoring rules, and they're using those bugs to sabotage other teams' attempts. I'm not sure we want to encourage that, but I'm going to call that winning. Okay, so as I mentioned before, I come from a front-end background, so working with UX is normal for me, and we do this with our systems for SRE. Am I missing a title? No. So working with UX means you get good-looking tools. And when you get feedback like this, basically translated, that means I enjoy doing this, so I'm going to do it more. So the things that the actions you want people to take, they're going to do them more, which is going to improve your data. And it's not just about the visual side of things. So we go out and interview our users, and we find out what's wrong about the process we've got at the moment, and change things to help them. So there's a phrase in design which is kind of called good design is invisible. And I think building internal systems for engineers, we should think about that kind of thing more. And also, I forgot to say something on a previous slide, is that when we build, getting UX involved building our sort of public-facing websites, we talk a lot about conversions, whether that's getting people to book more stuff or something else to do with money. And I think internally, a conversion is getting someone to fill out the details in a form. So if we take that mentality of thinking about UX and conversion for our internal systems, we'll end up getting better results. So here is an example. So the data we put into this system, one view of it is runbooks, which is what our operations team use out of hours to support our systems. So what a problem we had was people editing their system code in GitHub, but authoring the runbook was something I did via some admin screens or via an API. So there's no kind of things will get out of step because there's two completely separate processes there. So we worked with teams and asked them, how do you want to edit stuff? So now we are almost finished building something where teams, they write runbooks in a markdown file in a repo, and we detect production changes, and then suck that up into the BizOps database, and then it gets pumped down into this runbook file. So this is a prototype of that. And what this means is we'll get better runbooks because we're allowing people to edit them where they want to. We're understanding their problems as a user. And there's so much potential for this graph as well. Our plan is to add more and more interesting relationships, which will all these things I just mentioned, we can apply those approaches to them as well. So if people want to manage, let's say, their GDPR requests, then we can kind of build in virtuous cycles around that. So in summary, legacy code is something that comes to us all. You can't avoid it. But documented legacy code is a far better situation to be in than if it's undocumented. If you use a graph to model all your technical infrastructure, This gives you far more power than using simpler models. And using GRANDstack will make you feel like the film version of Mark Zuckerberg, which is, it's a mixed bag. Your data won't update itself, so you can create the system to contain it. Doesn't mean you'll actually get good information. But using approaches from UX and other kind of virtuous cycles can help keep the data fresh. Thank you.
Hi, cool talk. So you were basically addressing a side effect of having such a liberal ecosystem where people can use so many different technologies, right? And then that creates a problem that if people leave or move on, you have really weird stacks to maintain. Mm-hmm. But I imagine that you probably considered restricting the stack and the technologies used to minimize the problem instead of just having and addressing the side effect of it. Could you talk more about that?
So I didn't hear quite all of that, but I think you're asking kind of the balance between liberalizing it and you get all this bad side effects.
Yeah, exactly. I imagine that you probably reevaluated the option of restricting the technology zoo to minimize these problems.
Yeah, that's certainly something I don't think we're not looking at forcing people to take particular approaches. But I don't know if you're familiar with the term the golden path. That's an approach you want to take where you kind of make certain ways to building things. You just provide suites of tools which make them so easy and attractive that most people will do it, and making it clear if you use these approaches, you're going to get loads of centralized support. If you use other approaches, you're responsible for it completely yourself. So it's I don't think we'll ever go back to having every decision centralized, but there's approaches you can do. Again, it's about culture. You kind of can make it easier for the culture to be a particular way.
Thank you, Rhys.
Yeah, thanks.